project we are going to control a 5-phase permanent magnet motor. Comparing with 3-phase systems, 5-phase systems have several advantages. For example, the phase currents are lower for the same power, and in addition to the main harmonic, it is possible to control one of the current harmonics. These systems are interesting in automotive industries because they can continue their operation under faulty conditions. For example, when we miss one of the phases, or even when we have two faulty phases, it is possible to continue the operation with the remaining healthy phases. Here we can see the electrical motor. This prototype is open and we can have a look into the internal structure. As it can be seen, the configuration includes an outer rotor which allows us to directly mount the rotor inside the vehicle wheel. This motor has 26 pole tails. Here we can see the rotor magnets which are directly mounted on the surface of the rotor. And there we have the mechanical load, the real motor which is operating now, and the mechanical link. This mechanical link connects our motor to the load system and includes the torque sensor, the shaft encoder, and the belt which connects our load motor to our 5-phase permanent magnet motor. And here we have our inverter system. We have the inverter here. As it can be seen, the inverter includes 6 half-bridge modules and their related driver boards. And the whole system is mounted on these 2 heat sinks. As it is obvious, this system is designed for much higher power, which is because we are going to use this system in our future projects too. In fact, these bridges are made by Semitron Industries with the maximum current of 50 amperes and the maximum voltage of 1200 volts. The inverter is controlled by this DSP system, and the motor currents are measured by these clamps, and the whole control structure is developed in MATLAB environment. Here we have the DSP environment with the switching frequency of 5 kHz. Right now the velocity is fixed by load system, and we are able to see the current of 4-phase systems on the oscilloscope. As I mentioned, one of the advantages of 5-phase systems is that it is possible to control both fundamental and one of the harmonics. For example, right now I am going to increase the first harmonic in the quadrature direction, and now I am going to increase the third harmonic in the quadrature direction. This type of control is very useful in BLDC applications where the back EMF waveform of the motor is trapezoidal. Okay.